Welcome guys, welcome to the machine learning mindset. In this tutorial we're going to talk about custom training. It means this kind of training that you have a more control or on different loss function definitions, on optimization, etc. So this tutorial is rather advanced, so I encourage you to read our previous tutorials so far so you have an idea of what we're doing here in general, so I can spend more time on the details of more advanced concepts. Okay, so I'm importing TensorFlow and NumPy as usual, and here I'm loading the database and prepare the database and visualize some samples for showcasing. So in previous tutorials, I explain how I'm doing this stuff. So please take a look at them to have an idea what's happening here. Let me move on to the next step. Here we have databases, and by using this TF dataset object from TensorFlow TF data API, and from tensor slices I am creating my database. So let me show you more about what that is. Here, these are some sort of examples provided by TensorFlow. When you have specific NumPy tensors, you can use TF data from tensor slices to create a dataset object which is recognized by TensorFlow. This TF data actually dataset API has tons of different functionalities and makes life very easy for you. In general, it's rather complicated and it's not, the easiest to work with in the beginning, so I make things very easy for you here to just explain that all you need to know is to wrap this X train and Y train, which are the training images and training labels in a way, and then you just feed it to this, and that's all. You have your data set. With shuffling is actually we want to get the best of our training experiments. So because shuffling is truly important for our data, and with this dot shuffle buffer, we just shuffle our training samples in place, and with dot batch we batch the train data set. As simple as that. So it just everything is done by TensorFlow automatically. There is a caveat. This dot shuffle with the buffer size is actually very memory consuming. So if your database is large, you can't expect this thing to work. You're only limited for actually limited buffer sizes, but that's not gonna help your training, because when your buffer size is 1,000 and you have 1,000,000 sample, only the first 1,000 ones are the ones actually you use and shuffle, and that's something you don't want to use. So this is only applied for this scenario. In future tutorials, I'm going to talk about Python generators, a more efficient way of shuffling that you don't get memory issues. So stay tuned. Here I'm just creating train data sets and test data sets that we can use in TensorFlow. Simply, here the model that we defined in previous tutorials for multi-layer perceptron and convolutional neural networks. I investigate and demonstrated how and why we are creating these models, and later on we are just going to define our loss function. So this loss function was something that I used previously in one of our tutorials in Keras. Simply we use this sparse categorical cross entropy with logics with false here, and the accuracy metric of simple TF Keras metrics accuracy. We check one predicted label with the ground truth and report the accuracy. So these are two functions we need. The first one is the loss function, which based on the loss object, the predicted values and ground truth labels is going to report the loss. Here is the accuracy function, which we actually have basically calculated for the outputs. We use the argmax to return the probabilities of some predicted class label, and then we report the accuracy with the accuracy metric that we defined above. So I'm going to go ahead, define an optimizer, Adam optimizer with the default learning rate of 0.01, and here's my training begin. So for epoch, in number of epochs, which I define here, and for here I'm just creating two empty lists, running loss and running accuracy, that I'm going to show you how I'm going to use them. Then this is each training step for each epoch. So it says for input and target in the trained datasets, which is the way that we so-called the trained datasets we created by TensorFlow. With gradient tape as tape that we are watching the gradients, we get the input, feed it to the model, and create the output. Then we calculate the loss, we calculate the accuracy, and by tape gradient, we are going to optimize and track actually the gradients. When we track, well, actually here the gradient calculation is happening on the trainable variables on the model. Here, the calculated loss is going to be saved, and the calculated accuracy is going to be saved as well. Then we are going to run the optimizer based on the calculated gradients. We need to zip the gradients and models trainable variables to apply the gradients. Then after each epoch, we are going to mean the loss and running accuracy list that we created by tracking everything inside one epoch. Then we report the epoch loss and epoch accuracy, as you can see through the training. And later on in the calculating of the test set, we are going to use the test data set now. Again, we feed the model, we calculate the accuracy, and we append the accuracy for actually each step. Then in the end, we take the average of accuracy to report the test accuracy overall. So as you would see, this is much more, I wouldn't say it's much more sophisticated, but at least more sophisticated than the high-level Keras API. With all of these lines could be done with just simple model.compile and model.feed. But this sort of gives you much more flexibility in defining the way that you're trying your training loop to go. So this is a sort of custom training loop that you actually desire to have specifically when you have a model, when you want to debug, when you want to see different steps to don't lose the clue. So it is recommended when you truly need to know every single detail and you care. It's mostly recommended for research purposes because you can change everything. You can spoon by spoon investigate the stuff. Okay, so this was a detailed overview and showcasing of how you can have a custom training loop and how you can actually control different aspects of your model. And this is actually what you want to do, as I mentioned, if you want to work on a sophisticated model. Okay, I hope you enjoyed it, and feel free to comment below if you have any question or point of view. Thank you so much for watching.